All right, check, mic check. Good day, everyone. Welcome into another live stream. Dr. Drew coming at you with another live stream today. Guys, how's it going? Let's wait for folks to chime in. Right now, I'm on IG and TikTok today. Guys, today is November 17th, 2025. Crystal, welcome in. Casson, Dennis, Aaron, welcome in. Hey, how you doing, my friends? It is Monday. Yo, Jackson in the chat. Billy Hooper, welcome in. Folks, goaded. Know you. Hello, Dennis, Riscott, Sita, Sam, Pita. Welcome in, my friends. We are literally just getting started for today. Guys, question of the day today is going to be a little bit different. Usually I ask you, what are we going to do? Math, chem, physics. But we already have lots of requests in the Discord. So we're going to do OChem today and Gen Chem. Gotta go to bed. You're in EST, aren't you? Bye bye. What's up, Joey? The Go Joey. Is that time of the day, guys? Starting late today because I pretty much had sessions all day. I had a fluid mechanics session today and thermo. Super excited for thermo and fluids. Guys, question of the day: what is the most confusing thing in chem? We're gonna do chemistry today. And guys and gals, welcome into the live stream. We're literally just getting started. How's everyone doing? Super appreciate y'all's interaction. And yeah, how are we doing, my friends? It is November 17th. And guys, so what is the most confusing thing in chem? What is the most confusing thing in chem? That's going to be the question of the day. Probably how the bonds work. Ooh. Probably how the bonds work. That makes sense. That makes sense. Absolutely. And guys, so we have tons of questions in the Discord. So I'm going to go ahead and uh, pretty much just get started. If you're new here, you already know. No, if you're not new here, comment the no, excuse me. If you're new here, comment the word new so that we know that you're new. And if you've been here before, you already know, comment that lock emoji. Guys, we're gonna lock in for about 1 hour today. And we're gonna be recording this live on TikTok and Instagram and YouTube, so you can rewatch this on YouTube. Fumble the intro. Before we get started, I just want to let you know my name is Dr. Drew, and you're watching Engineering Minds. So, guys, if you tap that link in my bio or go to engineeringminds.co, you can check out the website. You can book tutoring, check out the resources, and join the Discord. The Discord is 100% free. And as you know, if you need tutoring, I got you for various STEM subjects, including math, chemistry, and physics. All right, fumble the intro. Okay, we're gonna jump into the Discord, and let's see what we got here. So we got tons of stuff here, um, and where are we here? I'm gonna go ahead and do chemistry right off the bat today. I'm gonna jump into chem, and let's see here. So we have these, and this is gonna be R versus S configuration. Shouts out Jackson for the awesome website. So let me move this real quick. Okay, and then let me move this. So guys, comment down below what is the most confusing thing in chem. And cool. So here's gonna be the first question from the Discord. And I wonder if, let's see. Guys, what if I do this? Okay, I think I might switch to landscape soon because there's gonna be more room. So I don't have to edit anything for YouTube. And guys, we're gonna go ahead and do these problems. These are from OChem. And once again, if you guys have any questions, feel free to drop them down below. We're gonna keep it chill. We're gonna jump right into OChem today. And yeah, feel free to follow along, drop in some questions. Let me know how's it going. November vibes. You already know. Okay, cool, sweet. So our first topic is gonna be R versus S configuration today. It says, designate the R or S configuration for any chiral centers in the following molecules. So we're gonna go one at a time here. And chat, if you know how to do this, comment down below. What's the first thing we have to do here? And what's up, Logan? So we're gonna do here's our chiral center. So a chiral center is what, chat? So determine the R versus S configuration. So a chiral center is anything that is a carbon that is attached to 4 separate R groups. Ali, welcome in. And guys, so right off the bat, we see this carbon here. It's kind of, so sometimes it's going to be hard to tell where is a chiral center. So right now I have H versus OH. Landscape streams. Yeah. And then just the only question is, can my computer hang? Okay. So this right over here, you know, these are not chiral centers because they have like multiple of the same things. So for instance, you know, over here we have H's. So these are not chiral centers. However, over here, chat, is that a chiral center? I know I have a laptop, bro. Right over here, this is a chiral center because we have H and OH is literally different here. And this entire chain on the side here, this yellow chain, I'm going to call it as yellow. Think of this as one giant R group, and then this over here is another giant R group. So we have 4 different constituents. So here's our chiral center. I'm going to put a little dot right there. Ethan says R. Great. So the next thing we have to do is label the R versus S. We have to label the constituents based on atomic mass. So I'm going to put a 1 over here because oxygen has the greatest atomic mass. So oxygen is number 1. Giselle, welcome in. Ethan, Nita, thank you for the follow. Stalking, welcome in. Giselle, thank you for the love. This is going to be a 4 right over here for the H. And because H is the least atomic least atomic mass. Now, here we have a tiebreaker situation here because we have carbon here attached to another carbon. So this is a carbon. So we have to do a tiebreaker. Okay? And we're going to do a tiebreaker here. So we have carbon versus carbon. So we need a tiebreaker here. So we're going to go to the next bond over that is the greatest atomic weight. So we're going to go to the next bond over, which is the greatest atomic weight. So we have H, H, and H. So we're not going to go with H. We're going to go with the carbon. So we're going to go 1 over here and 1 over here, and then hop over 1 more time to this carbon here and this carbon over here. Great. All right. So, okay, interesting. I don't think I've done this one, chat. I don't think I've done this one before. So now we have another tiebreaker. So usually we see the tiebreakers stop at this point. But chat, I think this is my first time seeing, do we select this carbon as our new tiebreaker? Or yes, we do. Okay, so I take it back. So now we're over here and over here. So that's another carbon attached to another carbon. So the problem, chat, is we have 2 carbons that we have two tiebreakers here. Now we're going to go to our third tiebreaker here, and we basically have this carbon over here and this carbon over here. Okay, so that's going to be our third tiebreaker, and just to keep it simple, let me erase all of that, just to keep it really, really simple. This orange group is in a way bigger, it's bulkier, okay, compared to this yellow group. So therefore, this one is going to be number 2. And this one is kind of smaller. So therefore, this one's going to be number 3. Okay. Now the rule is if 4 is dashed, we're going to go 1, 2, 3 clockwise. That's going to be R. So if 4 is, let's write a little side note here. So side note, if 4 is dashed, which it is, we're going to say clockwise is going to be R and counterclockwise is going to be S. But if 4 is wedged, what is that going to be? That's going to be the opposite case. We're going to say clockwise is S and counterclockwise is R. So we see our groups is 1, 2, 3. Is that clockwise or counterclockwise, chat? Is that 1, 2, 3 clockwise or counterclockwise? I see that 1, 2, 3 compound is going to be 1, 2, 3. That looks like it's clockwise to me, so I'm going to say R. So I agreed with Ethan, who said R for Ethan. So the tiebreaker was basically this was bulkier. Ayana, because it's branch, it's bulkier. Exactly, it's branch, it's bulkier. Branch. Do you have a video of this? Shaw, I'm not gonna lie. I have a video on chairs, but I'm lagging it on the R versus S. Let me hop on that. Guys, who's ready for the next problem? Anyone that's just joining in, welcome into the chats. We're live here on IG and TikTok, but I am recording this. So if you want to rewatch this from the beginning, I'm gonna post this tonight or tomorrow. Okay, yes, I'm recording this right now, guys and gals. Welcome into the chat. Anyone that's new here, comment the word new. And if you've been here before, comment that lock emoji. We are locked in today. So if you're new here, comment the word new. Guys, let's do the next one here. So where's our chiral center here? Where's our chiral center? So anything, chiral centers are only carbons, by the way. So anything that is oxygen is not a chiral center. So eliminate this, eliminate that. Anything that has a double bond, okay? We're going to eliminate all the nitrogens here, okay? So we're also going to eliminate this one because this is not unique to this one here, okay? Ethan's really fast. Ethan said R. So we only have one chiral center. And, okay, Catcher, welcome in. Catcher's new. I just had an Orgo lecture, so I'm going to watch that for my upcoming exam. Perfect, Shaw. Like I said, I'm going to be posting this on my YouTube tonight, latest by tomorrow, so you can rewatch that. And guys, I go live every single week, Monday through Thursday, right around this time to answer your STEM questions. Guys, drop a comment. Question of the day is, what is the most confusing thing about chem? Is it going to be organic chemistry or gen chem? And then perfect. So guys, now we're going to label our 4 constituents here. We have this H group is a constituent here. We have this OH group is another constituent. I'm going to color this entire side chain here. This is a really, really large constituent, R group. And then lastly, we have our final constituent over here. So again, we have to number it based on the atomic weights. O is a really, really massive, so that's going to be number 1. And H is going to be the least massive. That's going to be 4. Now we have to do our tiebreaker business once again. So I'm going to go here, and then I'm going to jump and compare here and here. So we have carbon versus carbon, so we need a tiebreaker. And then we're going to hop over to the next biggest one. So I see the oxygen is next biggest here, but then I have a carbon compared to nitrogen. So therefore nitrogen dominates compared to the carbon. So I'm going to say nitrogen dominates. I'm going to call that one a number 2. And this one's a carbon number 3. Chat, if that made sense, why nitrogen is dominating, go ahead and drop a thumbs up. Okay, if that made sense, why nitrogen dominated the carbon there, go ahead and drop a thumbs up down below. Gen Chem calculations go crazy low-key. No, I agree. Dude, Gen Chem calculations go crazy. Okay, I'm not going to lie. So then we're going to go 1, 2, 3. It's R again. Okay, so remember, the rule is if it's 4 is dashed, clockwise is R. We have 4 is dashed. Okay, and we go 1, 2, 3. Is that clockwise or counterclockwise? 1, 2, 3. That looks like clockwise to me, so therefore it's R. Guys, let me know if you have any questions about this one here. Upper Intuitus didn't quite get that. Guys, let's do another quick example. Yo, Angel, you're from UCR, bro? EE right now. What year are you, my friend? I was chemi, bro. I went to UCR too, bro. So wouldn't it be because CH2 is attached to NH2? Yes. So that's why it's a tiebreaker. So NH2 dominates. So even if O is on the second carbon, we consider it to number them. Okay. Wait. So I don't think I got that show. Even if O is on the second carbon, we consider it to number them. O is too far. O is too far. We don't consider O until we touch it. O didn't dominate because O did not touch the carbon. This carbon was closer to this N. Okay? Guys, I'm going to continue on to the next problem. If you have any questions, drop them down below. I'm going to continue on to the next example, and then you can rewatch the live stream later today. Guys, anyone that's new here, comment the word new, and then drop your questions. I'm gonna answer them in the order in which I receive them. And then, guys, you can also join the Discord for free, link in bio. Okay, this is a question straight from the Discord. Okay, guys, so where's our chiral center here? So none of these are chiral centers because all of these have our H's here. So these H's are not unique constituents. And then double bonds are never chiral. You can't have chiral. Now, what about this one, chat? This one looks This one looks suspicious. This one looks low-key sus. So I'm going to circle that one. And then this one's definitely a chiral center. So let's look at the one on the right first. So the one on the right is chiral or non-chiral? Chat, do you think that this one on the right here, is that chiral or non-chiral? So if you think it's chiral, comment the word chiral. If you think it's non-chiral, comment achiral. Okay. Meanwhile, while you guys are discussing that, let's think about this one here. Okay. Are you able to post these notes? Of course, Dina. This one is right for you to post later in the Discord. Okay, I'm gonna take a screenshot and then tag you. And then guys, so I'm gonna look at this one here. This one is certainly chiral. Why? Because we have 4 different constituents. So I'm gonna color this one in yellow. And then I'm gonna color this one in purple here. This one I'm gonna color this one in, like, let's say red. And then chat, what's your favorite color? Let's say whatever chat's favorite color is, I'm gonna color that last one. Okay, good. Everyone says achiral because this is symmetrical. So guys, this is achiral because this pentane this cyclopentane ring is symmetrical. But if there was something else, for instance, an OH over here, then suddenly it would be achiral. If there was suppose there was an OH wedged here, it would be chiral rather. But because there's nothing there, we're gonna ignore that one. That's gonna be achiral. Okay, so chat. First one I saw was pink. No, blue. First one was Nelson, was blue. Okay, so this is gonna be our blue one here. Okay, guys. So better question: is it R or S? Exactly. That's the question. Okay, designate R versus S. So chat. Remember, we're gonna make our 4 our least massive atomic weight. So H is typically 4. And then guys, we're gonna make which one's gonna be number 1? So oxygen is the most massive here, so that's gonna be number 1. Now we have another tiebreaker. So we have another tiebreaker here. So we have carbon versus carbon, and these are all carbon. So we have a small problem. However, double bond is a stronger bond. So double bond means it's like stronger. It's gonna dominate. So we're gonna say double bonds dominate over single bonds. So therefore, we're gonna say this is number 2. Okay. So this one's number 2, and then this one's number 3. Okay. So again, H is the smallest, O is the biggest. Double bond dominates over single bonds. So we have 1, 2, 3. Okay. We have 1, 2, 3. And that's going to be, is this clockwise or counterclockwise, chat? All right, Nelson is spamming S, guys. Is this clockwise or counterclockwise? So guys, this is going to be clockwise or counterclockwise. I see this is clockwise. So typically that's R, but Nelson is correct, okay? If 4 is wedged, then clockwise is actually S. So guys, remember, if H, which is 4, is wedged, it's actually going to be the opposite case. It's going to be S here. Guys, drop any questions down below if you have them today. Lala, welcome into the chat. Just catching up on the chat. If I miss your question, just go ahead and retype your question down below. Guys, my name is Dr. Drew. I go live every single week, Monday through Thursday, to answer your STEM questions. Today we're going over organic chem. And wrong H flip. Because if H isn't in the back, clockwise, but if it's lowest priority, it's the opposite is true. Exactly, right? So guys, let me know if there's any questions here. And Hafsa says SN1, SN2. That can be definitely next. Okay. Right now I'm just going from the Discord. And guys, if you want to join the Discord, it's 100% free. Let me just pull that up real quick. Okay. Go into the website. Go to engineeringminds.co or tap the link in bio. And this is where you can join the Discord if you want your questions answered. Okay. So just join the Discord link in bio. Go to engineeringminds.co. All the information is on the top of the screen. Click this link that says join Discord so that way you can ask questions and get free homework help, okay? So all you have to do is fill out this short survey. And last but not least, guys, if you need any tutoring, I got you for various STEM subjects. I can do OChem, Gen Chem, Calculus, and Physics, okay? Scooby, welcome in. I'm not wrapping up. I'm kind of just getting started today. And we're going to go on live for about 45 more minutes. Guys, comment down below. What's the most confusing thing about chem right now? Comment down below. That's the question of the day. And guys, we're going to go ahead and continue on for the next problem here. So guys, if you're logged in, go ahead and comment that lock emoji. So if you're actually following along, taking notes, okay, don't be scrolling on your bed. get off your bed, and actually follow along, take notes. Comment that lock emoji if that's you right now. All right, so now what we're gonna do is identify the chiral centers. This one has multiple chiral centers, chat. So how do we know if something is chiral or achiral? Remember, something that is chiral is gonna have 4 different unique constituents. My hair is locked in. Heart says electrochemistry, redox. Okay, I'm getting multiple requests for alkenes, so I'm gonna do alkenes in SN1, SN2 next. Guys, and remember, I am recording this, so I'm gonna post all of this later today, so you can rewatch it on my YouTube channel. Okay, and then guys, I see these highlighted groups are 3 chiral centers here. So we gotta go one at a time. This time we're gonna go a little bit faster here because we have a lot. We have 3 here. So guys, this one is chiral because I see that this one is gonna be 4 different constituents here. So I see 1, 2, 3, 4. So let's start here. Okay, chat, I need 4 different colors, please. I need 4 different colors. I'm gonna start with H here. Drop your favorite color, my friends. So this one's gonna be the first one, is gonna be yellow. Okay, and then this one is gonna be our next one here. I'm gonna color this one orange. Okay, and then chat, I need a couple more colors, my friends. So I think I saw earlier, I think I saw pink. So let's see what pink's gonna look like here with highlight. Okay, so I'm gonna add this one here. All right, and my here says blue. So chat, we have 4 different constituents. That's what makes this a chiral center, my friends. So we have 4 different constituents. That's what makes this a chiral center. So this entire thing is a constituent. Okay. So chat, we gotta number this 1, 2, 3, 4. So right now we have a triple tiebreaker. Do you also do lives like this for calculus? Absolutely, we did calculus last week. So guys, we have a triple chiral. We have a triple what do we call it? A triple tiebreaker. H is 4, and then we see we have carbon 3, and then we have another carbon, carbon, O. So right now we have a tiebreaker because we have carbon versus carbon versus carbon. So we're gonna have to do a tiebreaker. Now, to do a tiebreaker, we have to go 1 over, move 1 over, okay? And then we have to basically identify which one's the strongest fighter. So which one's the strongest fighter, okay? This is where I get confused. CH3 is 1. Okay, so now C is a tiebreaker, C is a tiebreaker. So we're gonna go 1 over to the side. So the next one is oxygen. So now we're comparing oxygen and then H, and then the next one is another carbon. So now we're comparing carbon to oxygen to H. Okay, oxygen is gonna dominate here. Okay, so oxygen is gonna be number 1. So the orange one I'm gonna put as a 1. Okay, and because now I'm looking at oxygen, hydrogen, and then another carbon here. And then carbon is gonna dominate H, so I'm gonna put that one as a number 2. And then finally CH3 is number 3. Okay, so therefore we're gonna go, our H is dashed, so that's gonna be our typical one. So we have 1, 2, 3, and so the rule is if it's 1, 2, 3 counterclockwise, that's gonna be S. Okay, so the rule is if 4 is dashed, then counterclockwise is S. Remember, we go in order 1, 2, 3. 1, 2, 3 counterclockwise, dashed S. Okay? If you didn't get that, follow along, lock in, and we're gonna do that again. We're gonna do that again for the next one. So ready to lock in, chat, comment that lock emoji. Okay, chat, what's our next chiral center? What's our next chiral center? Remember, we need 4 different constituents, so I'm gonna highlight this one as the chiral center here, chat. So this one is the next chiral center here. This triggered me by showing this on my FYP. Is there not a CH2 on the OH? There is a CH2, but we're going to ignore the H's because carbon dominates H. Okay, I'm going to explain it again right here. I'm going to explain that one more time right here. So we have 4 different constituents. I'm going to highlight these different colors. Chat, I need some more colors, my friends. What's everyone's favorite color? I need 4 different colors, my friends. So guys, my favorite color is blue. What's y'all's favorite color? Okay. And then I'm gonna color this entire chain is gonna be a yellow chain here. Okay, purple. Thank you, Birita. Hopefully I'm saying that right. Pink and green. So I'm gonna put this one as pink, and then another one I'm gonna say green. Okay, chat. So now we have our chiral center here. So we have our 4 different chiral centers. So remember, we gotta carefully go. Oh my gosh, I erased the S. I didn't mean to erase. This is still S. Okay. So our 4 is H. Our 4 is H. So this one's H is usually 4, chat. H is usually 4. So H is usually 4, and then nitrogen is going to be, okay? So now we're going to compare nitrogen to carbon versus carbon. So nitrogen is going to dominate carbon because it's heavier. It has a greater atomic mass. All right. Okay, I'm getting a lot of requests for alkenes. So this is gonna be our last one for R versus S, and I'm gonna jump to alkenes and alkynes. Okay, thoughts on working in a medical lab? I mean, absolutely. If you got accepted to one, do it. What kind of questions about working in a medical lab do you have? I haven't worked in a medical lab. I've worked in a research lab. Okay, and then CH3, CH3 compared to CH2. So now we have another carbon versus carbon tiebreaker. So we have carbon versus carbon tiebreaker. We got to go 1 over. So we're going to choose our greatest fighter. And my next greatest fighter, I want to jump to this oxygen here, because this one's pretty close. This one's strong. So I want to get to the oxygen here. So then my next greatest fighter is this carbon. I have no choice. I'm just going to go to carbon. Okay. So right now I'm over here. I have carbon versus carbon here. So that's going to be another tiebreaker. And then I have carbon versus oxygen here. So now I have oxygen is going to dominate this carbon. Okay, so now this green is going to dominate the yellow. So green is going to be number 2. And then yellow is going to be number 3. Okay. So yellow, the next one I think is CH2. Correct. Guys, let me know if you guys understand this tiebreaker business here. Danny, what were you asking about being in a medical lab? So why is it not yellow CH2 and then green? Just C because it has 4 bonds? So why is it not yellow? Okay, so let's do that one more time. So we agree that N is number 1 and H is number 4. Okay, so green versus yellow, chat. Green versus yellow. So how do we know if it's green versus yellow? So right now we have carbon versus carbon, so we need a tiebreaker. So we're going to go 1 over. Now, we're not going to choose H because H is not our best fighter. We want to choose our best fighter. So we're going to ignore the H and we're going to ignore the little h right here. So ignore this H, ignore the H right here. We want to go 1 over to the strongest fighter. We're not going to go to CH3 because I see I have a double bond O right here. Okay, so I'm going to hop over to this side here. So I'm going to ignore this H, I'm going to ignore this H, and I'm going to ignore the little H's right here. Okay, so now I hopped 1 over to the side. Now I'm over here, and then I'm over here. Okay, so now I have a carbon, okay, bonded to another carbon. So this is another tiebreaker. So I erase this and erase this. So we need to hop over one more time. So I'm not going to choose this H because that's a weak fighter. I'm going to choose the oxygen here, and then I'm going to go to this carbon. Okay, so it's oxygen. It's basically oxygen versus carbon, and oxygen dominates. That's why it's number 2. Okay, that's why it's number 2. Chat, let me know if that made sense. And then once again, once you review this and once you do it 3 times, it's going to make a lot more sense. All right, so now we have 1, 2, 3, and guys, our H is dashed again, so that's normal. So 1, 2, 3, this is counterclockwise, so H is dashed, this is S. Okay, so this is H is counterclockwise, so that's why we got S here. And guys, we have one more chiral center. Where's that final chiral center going to be? We have one more chiral center onto this carbon. Let's see if we can find it together. Guys, where's our last chiral center? Let me know if you see it. And we see that our chiral center, remember, is 4 different constituents here. So the green side with the X, that's not considered C because it has 4 bonds. I'm sorry, twin. Let me go back here. Let me address that. So the green side with the X, that's not considered C because it has 4 bonds. This one's considered C. This one's considered C. And this one's considered C. Now we're going to look at that one. Yep, now we're going to look at this one. Okay? Now we're going to look at that one. So this one was still dominating. So now we're going to do a third one here. Okay? So now our third chiral center is going to be right over here for that very reason. So we have 4 different constituents. Okay, so what other colors am I missing here? Was I missing any other colors? Okay. Oh, someone said can't see. Chat, is it too wide? Chat, my apologies. Let me make this smaller. Let me make this one smaller, and then let me make this one smaller. Was it too wide? Let's try to fix that just like that. Okay, let's see if that's better. Okay, so okay, so let me try one more time here. So that's gonna be right over here is our chiral center. So I'm gonna color this one green, and this one is gonna be green, and this one's gonna be purple. Okay, and then this one's gonna be yellow, and this entire blue guy is gonna be an entire chain here. So chat, here's our third and final chiral center, and then we're gonna do alkenes here. Here's our third chiral center. Okay, so guys, we're gonna see this is gonna be a number, this is gonna be our chiral center here. So we basically have 1, 2, 3, 1, 2, 3, 4 constituents. Okay, so which one's gonna be, number 4 is always H usually, chat. H is typically 4. Okay, so then we have carbon versus carbon versus carbon. So my friend, hand heart emoji. This one's for you, okay? So we're gonna break it down slowly. This one's for you because I see you're a little bit confused about how to rank them. So this one's gonna be carbon versus carbon versus carbon, okay? And I appreciate you're locking in, so let's do this one together. So we need a tiebreaker here. We're gonna cancel out this carbon and this carbon and this carbon. Okay. So we know we have a triple tiebreaker because we have 3 carbons. All right. So I want to choose my best fighter. So I'm not going to choose this H for this carbon. Okay. I'm not going to choose this H because I know that this H is not my best fighter. So for this carbon, I'm going to hop over to this oxygen here. So right now, my oxygen is my best fighter. Okay. So for the green one, oxygen is my best fighter here. All right. For this pink one, I don't have any other choices. My best fighter is my H. Okay? My best fighter is my H. I don't have any other fighters. Okay? So H is going to lose here. And then on this carbon here, okay, now I have some choices. Do I want to go to the left because I have another carbon, or do I want to go to the right? I'm going to choose my right one here because I have nitrogen. So therefore, I'm basically comparing the triple tiebreaker. I have oxygen versus nitrogen versus carbon. All right, the heaviest one of these is going to be oxygen. So I'm going to put this green guy, I'm going to put this as number 1. Okay, and then nitrogen was my next best fighter. This was going to be number 2. And then finally, CH3 is going to be number 3. Okay, there you go. Is that making sense? You said O is, exactly. Then N, okay, there you go. Then N is next big. Okay, and then carbon is the last one. Makes sense? Makes sense? You have to practice it, okay? You have to practice it. It's going to suddenly click. Now, the last step, chat, remember, H is dash. That's what we want. So we're going to go 1, 2, 3. Okay, 1, 2, 3 clockwise. Okay, 1, 2, 3 clockwise is going to be, that's clockwise. That's R. Okay? So chat, I'm going to go ahead and zoom out for this. And then this is going to be our first problem for today. And then I'm going to drop this into Discord. And then chat, we're going to go ahead and see what's the next question into Discord. Okay, once again, if you guys want to join, it's 100% free. So I'm going to drop this and then tag the person that asked this. And then let me see where's my next question here. So we're going to stick to OChem for today. And then we're going to see if there's any other questions here. So this is going to be the next question here. Okay, this is going to be the next question. So once again, if you want to join the Discord, just tap that link in bio. Okay, tap that link in bio. Click, go to engineeringminds.co and then click on join Discord so you can get your questions answered. Okay, the next best fighter, it clicked for me, right? I love that analogy, right? I think that's when it clicked for me too, low-key. And chat, we're basically going over all your STEM questions, whether it's math, Gen Chem, OChem, physics. You can comment down below, or you can answer the question of the day. What is the most confusing thing in chem right now for you? Okay, be honest. Comment down below. And guys, so here's our next question. And all right, and then guys, we're gonna do basically this problem here. So curved arrows are used to illustrate the flow of electrons using the provided starting structure. Draw the curved electron pushing arrows for the following reaction or mechanistic steps. Be sure to account for all bond breaking and bond making. Then draw the organic product of this reaction. So include all lone pairs in the structure, ignore inorganic byproducts, counterions, and solvents. All right, so we're gonna basically do Okay, we're gonna basically do what do you mean nauseous? Okay, so we're gonna basically do this constituent here. We're gonna basically draw the bromine here, and is that another carbon here? What is that looking like? Okay, it's a little tricky, but I see that we have like basically a carbon, 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 just like that. All right, so then we're gonna react it with this guy here. So I'm gonna draw this arrow. It's basically gonna be just like that. Okay, and just like that. So chat, once again, if you need any tutoring for OChem, make sure you DM me, my friends. Okay, you can DM me your practice problems, or let me know if you want to schedule some sessions. Okay, I got you for OChem. I can understand for sure this topic is really confusing. So guys, we're gonna have, what kind of mechanism do we have here? Okay, what kind of mechanism do we have here? Is this gonna be, what kind of reaction do we have here? Is this gonna be, what is this, a substitution reaction, elimination? So guys, in the Discord, I already dropped a huge table that you need. Okay, you need to check out this table, and guys, this table is going to save you for SN1, SN2, E1, E2. So it's gonna try to find that here. I'm gonna reply to myself here and drop this table. Okay, so guys, let's take a look at this table together. So this is gonna be SN1, SN2, E1, E2 table. So guys, so if you're confused about SN1, SN2, E1, E2, you need to download this table, which is in the Discord, my friends. So we have to look at what we have here. We need to look at what kind of constituent we have. Do we have a strong nucleophile or a strong base? Okay, so guys, let's look at the reaction one more time. Let's look at that reaction one more time. Okay, so again, we have, this is a C CH3 C double bond O, and then O minus here. Okay, Nali, thank you for sharing. And guys, my friends, so now we have this compound here. So now let's take a look at that table and analyze what kind of mechanism we're gonna have here. So we're gonna look at the table and we compare, what's that base gonna be? Oops, I gave it away. So it's gonna be O minus here. Okay, this is O minus. So that looks a lot like this one here. Okay, that's RO minus. That looks a lot like this one here because that is going to be an R group. That's basically an R group with an OO minus, just like that, chat. So that's going to be my O, just like that. So that's an OR group. So this is R. Okay, so that yellow part is R, and obviously the O is O. Okay, so it says if something is primary versus secondary or tertiary, that's going to tell us which one dominates. So if something is primary, it's going to be SN2 major, okay? And if something is secondary, it's going to be E2 major, and then if it's tertiary, it's going to be E2. All right, of course, Riley, what's your question, my friend? So then we're going to go to this one, chat. Is this going to be primary, secondary, or tertiary? Is this going to be primary, secondary, or tertiary, my friend? So how do we know if something is primary, secondary, or tertiary? Okay, so we need to identify the leaving group. So which one's the leaving group? Okay, very good. It is a strong base. Okay, so guys, which one is the leaving group? And so this one's gonna be, you can identify the, yeah, it's tertiary. Very good. So the BR, to me, the BR is sticking out like a sore thumb. So the BR, hello, period. How are you doing, my friend? And the BR is going to be our leaving group because it's a, what do we call this? Is going to be a halogen. So now we see how many constituents it's attached to. I see 1, 2, 3. So therefore, this is going to be tertiary. So this is going to be tertiary. And so therefore, that's going to be our E2 mechanism. So how do we know that it's E2? Because we saw that if it's tertiary, it's going to be E2. All right. Okay, so therefore, now the next thing is, are we going to go Markovnikov or anti-Markovnikov? Do we want to go with the most constituents or the least number of constituents? So let's generate two mechanisms here. Let's generate two mechanisms so you can see what it's going to be. So in one universe, let's pretend we're in two alternate universes. So in one universe, and remember, you have to understand what the E2 mechanism is. And fortunately, I already made a TikTok on E2 where I explain it using a skit. And so E2 I feel like is like a breakup. So the O minus is going to attack one of the H's. Okay. And then, yeah, my friend, if you want to join the Discord, it's 100% free. Okay. Or you can DM me. Thank you. Thank you, chat. Appreciate you. Discord is in the link in bio. Tap that link that says Engineering Minds and then click join Discord in that link. I can show you right now if you stick around. So guys, we're gonna go ahead and do our 2 reactions. So in one universe, I'm gonna attack one of these H's here. So I have all these H's right over here. So I have an H right here, I have an H right here, and I have an H right over here. Okay. So then in one universe, I'm gonna just randomly attack. In one universe, I'm gonna randomly attack. Hold on, chat. I gotta fix this real quick. In one universe, I gotta randomly attack this H over here. Okay, and what that's gonna do, that's going to create a double bond on this alkene group, and then that's gonna kick off this leaving group up just like that. All right, perfect. And then so we're gonna have a set of single bonds, and we're gonna create an alkene. So that's called the E2 reaction. Do I tutor for OChem 2? Yes, I do. Okay. And then that's gonna be our first mechanism. All right. And then our next mechanism in a different universe, we're gonna go with this side here. So we're gonna attack this proton and then kick it off just like that, and then kick off the leaving group just like that. So that's gonna be our E2 mechanism. Again, if you guys want to review this, let me know. Okay, so we're gonna kick off that. And guys, let me try to draw a little bit neater because sometimes I get roasted when it's not neat. So that's going to be our line here, and that's going to be our double bond line just like that. And then we're going to draw like that. Okay. So that's going to be our second product. Okay, so now the question is, which one dominates, chat? Which one dominates? So is this going to be Markovnikov or anti? Okay. Why that specific H? Okay, now we're going to address that. So in this universe, we attacked this H. And in this universe, we attacked this H. So which one's going to dominate? Theoretically, they both happen. Okay, theoretically, they both happen. So the way I like to do this is wherever the alkene bond lives, I'm going to highlight that alkene bond in yellow. I don't know about you, but I feel like alkenes are always yellow or blue. Actually, I feel like they're blue. I don't know about you, but I feel like alkenes are blue. Okay, so I'm going to highlight this in blue. And then I like to put a little red dot at the end here. So I'm going to put a dot right here and a dot right here, and then a dot right here and a dot right here. Okay, so now we're going to count how many more is it going to have here. So are we going to have, so this one has how many on the dot? So I have 1 on the dot here, and then I have 1 and 2 on the dot. So I'm going to say that this is 0 plus 2, okay, equals 2. And then how many on these dots? So I see I have 1, 2, and then 3. So I have 2 plus 1 equals 3. Okay, so therefore 3 is greater than 2. Okay, but 2 is less than 3. So the one that has more, this one's called the Hofmann product. The one that is more, this one's called the Hofmann product. Think of it as like the universe with the more product. And then in this universe, this is called the Zaitsev. Okay, and each base is going to determine which universe we're in. Okay, now are we going to be in Zaitsev or Hofmann, chat? Are we going to be in Zaitsev or Hofmann? And then comment down why. Okay, so is this universe going to be the Hofmann product or the Zaitsev product down below? Okay, sounds good, Brandon. I'm going to check the Discord right after this. Okay, I'm just going in order. Guys, so is this going to be Hofmann or Zaitsev? So let's see what happened here. So let's see what our friend said in the Discord here. So our friend said basically they went with the Hofmann elimination. Okay, but I think that's not correct because this is a strong base, so it's gonna basically, it's kind of bulky, so I think it's gonna be a little bit I think it's gonna be Zaitsev, chat. Okay, so they did Hofmann, so we actually go with Zaitsev. Hey Twin, I got an 80. Wow, W. Shouts out Gab. Everyone say W Gab in the chat. W Gab. I'm not sure, Twin. How much are you studying? Hey Mahir, how much are you studying, my friend? Are you studying enough? Okay. So guys, we're gonna basically ignore the Hoffman one because they got it wrong. And the reason it's Zaitsev is because it's the one that is less substituted. Okay. Oops, let me go ahead and make this bigger. Okay. So I'm gonna screenshot this and then tag them. Okay, pop off. So let me reply to this person here. So, and then let me tell them that they got it. I think they probably confused Zaitsev versus the Hoffman. Okay, Zaitsev more favored due to less um, steric hindrance. Okay. Hindrance. I believe that's the theory. I might be a little bit wrong about the theory, but I think that's pretty much the general idea. Okay, so that was gonna be our E2 SN1, and we still got some more OCHEM questions here. So I think I see the next question here. Is gonna be basically have enolate and like 6 hours for the last couple of days. Okay, but here you're actually locked in, so you're studying enough for sure. If you're studying that much, that means you're locked in. That means now you have to work on your efficiency. You have to work on your efficiency. Yeah, it doesn't matter. It doesn't matter where you drop it in. I got it here. Guys, we're gonna just keep going. So here's nucleophiles and electrophiles. All right, guys, I'm still alive. I'm just kind of like locking in for this problem real quick. So it says, I think I got slightly triggered because I saw like bio and like your boy, guys. I'm not a medical doctor. I'm a PhD doctor. So every time I see bio, I get like a little bit of vomit. Get like a little bit of vomit come out. Okay. I'm just kidding, chat. Okay. Do you do personal tutoring sessions? Absolutely. Alexa, shoot me a DM, or you can sign up for a consultation call. Link in the bio. No worries, Brandon. And okay, perfect. So the molecule is a critical biological hormone. And it says identify all potential sites to serve as a nucleophile and discuss the nucleophilicity of each site. Okay, chat. So that's basically asking, okay, how do we know if something is a nucleophile? So remember, nucleophile means what? Let's just write everything here. So nucleophile means what? Love, like, right? Think like pedophile. As soon as you make it fun, it's gonna be way more fun. So think of like pedophile, or any other file. That's the first word that comes to mind. I can't think of any other file words. So file means what? Love of, right? So chat, I really need some more. I really need some more file words because all I can think of is pedophile. Okay, so file means love. Okay, so file means love of, and nucleo, what lives in the nucleus? Protons and neutrons. We have a positive charge, so we're gonna say love of positive charges. Okay, so nucleophile means we have love of positive charges. What loves positive charges? Electrons, negative charges. So nucleophile is something that loves positive charges. So what loves positive charges? Negative charges. So we're looking for anything that is going to have negative charges. I'm thinking this double bond O might be one. I'm thinking the OH might be one, and I'm thinking the alkene might be one. Okay, let's start with the alkene because the alkene is probably the most intuitive. So the alkene is going to be a nucleophile because alkenes are double bonds. So alkenes, I don't know why, but for me, alkenes are blue. I don't know about you, but for me, alkenes are blue. So guys, alkenes here are electron rich. Why are they electron rich, chat? Why are alkenes electron rich? So alkenes are electron rich because they have, they can do resonance. They have high electron density, there's pi resonance there. There's so much electron, there's so much electrons there. There's so much negativity there. So they're definitely gonna act as a nucleophile. Okay. And then what about oxygens? Oxygens are definitely going to also act as double bond O's are definitely going to act as nucleophiles. Why? Because of resonance also. So this entire chain right here is going to do resonance. So anything that has resonance, we're going to basically push that up, and then that's going to create an O minus here. So I'm not going to draw the whole thing, but it's basically going to be a single bond O, double bond, okay, and then R, and then we can call this R. So that entire chain is a big old nucleophile. Hold on, what did you say? Chick-fil-A-ophile. I'm a Raising Cane's-ophile. I don't know about y'all, I'm a Raising Cane's-ophile. Okay? And then the next one over is OH. Guys, is OH a nucleophile? That's up to debate here. So OH can act as a nucleophile in some context because it's going to basically it's going to act as a base. So for instance, if I have an acid here, and then our OH here is going to act as a base here. So I'm going to say the OH here is also a nucleophile as well. Okay? And there you go, chat. So there you go. So like I said, I'm recording this so you can rewatch that if you want to discuss that. But I think that's my answers here. Let me check the chat if I miss anything. Do you do MCAT tutoring? I do math, chem, gen chem, ochem, but no bio. Okay, I can do math, gen chem, ochem, but not bio or biochem. Okay, Alexa, make sure to do that. Perfect. Okay, SN1, SN2, E1, E2, Diaka. Hopefully I'm saying that right. I was just talking about that. You can see the Discord for the table where you can see where the table to show you how to do SN1, SN2, E1, E2. Okay, guys. So let me see. Dave's Hot Chicken. Dave's Hot Chicken is high key mid. It's not too late to delete this. Exactly, right? What about electrophoresis? Oh, electrophiles. Electrophiles is the opposite. Okay. So electrophiles is the opposite. So guys, now let's continue. I'm just catching up to the chat. So now electrophiles is the opposite. So once again, now I'm thinking about all these different file words. Okay. Did you do the second part of the question too? Not yet. We're about to log in for that. On the question before, did you attack the hydrogen on the methyl group? Did you attack the hydrogen on the methyl group? What do you mean, did I attack the hydrogen? I don't think I attacked anything, my friend. No, I didn't attack anything. We're gonna have to fight. I think we are because Dave's Hot Chicken is high key mid. Okay, Brandon, thank you for the follow. Guys, so the next question is identify all the potential sites to serve as electrophiles and discuss the electrophilicity of each site. So let me erase some of this. Guys, I'm having trouble finding any electrophile sites. So let's discuss electrophilicity real quick. So we said that those two sites are nucleophiles. Electrophiles are the opposite. So electrophiles are going to be love of electrons, love of negative charges. So therefore, what loves negative charges is going to be anything that has a positive charge. So I'm having trouble seeing any electrophiles here. I don't see any electrophiles unless you want to count the methyls as like very, very weak electrophiles. Question mark, but those are very, very weak electrophiles. Chat, let me know if you see any electrophiles here. I don't see any at the moment here. Okay, the ketone and the alcohol carbons. Yeah, I don't see any electrophiles, chat. Um, the the methyls like theoretically could be very very weak because carbons are technically slightly partially positive. So if you have to put something, I would say the methyl groups because carbon is slightly partially positive, partially positive. Okay, and so if anything, I would say those three methyl groups. But honestly, that's like stretching it. I would say I would say not really. Yeah, technically the H's technically. Oh, this one. Oh, now I see it, chat. This H here in red, that's our electrophile. Okay, because maybe because it's an alpha. It's an alpha. Hmm. I'm not sure, chat. I'm not sure, chat. I would say potentially these methyls and maybe this H is open to debate because this H is literally right next to this H. I mean OH. So if I, for instance, if I want to like deprotonate this guy, I mean, is it gonna happen? Probably not. But like, let's say I have like a really, really, really strong base. That OH minus is like starving. It's like starving for a proton. It's probably gonna eat this proton, and then this proton is going to potentially, yeah. You know what? Why don't we do? But see, this OH is a bad leaving group. This OH is a bad leaving group unless we add acid first. Chat, what if we do this? Hold on, chat. Let me cook for a second. Let me cook for a second. I'm gonna redraw that OH, and then that I'm gonna draw that H right over here, and then I'm just gonna put R because I'm lazy. Okay, and then I'm gonna put R1, R2 because I'm lazy. And then chat, what if we cook up for a second? What if we add acid real quick? So we're gonna add acid to first protonate the OH. Let me cook up something real quick, my friends. So we're gonna protonate this H here, and then turn the OH into a good leaving group here. So R1, R2, and then now this is an OH. Okay, this is OH plus. Okay, this is OH plus, and this is gonna be an H. Okay. And now if I add strong base, such as sodium hydroxide, then now I can eat this proton and basically create a double bond and do E1 here. Okay, so now technically I created a double bond. So yes, that H I think is now a it's a weak, it's basically a weak acid here. So yeah, it's gonna be the OH is a nucleophile, and then this H is an electrophile. Okay, that was a fun problem, guys. We have a couple minutes left. That's what I answered, so I'm open to debate. If you wanna leave any comments, comment down below, guys. We have a couple minutes left, and we're gonna do one more quick thing. What makes something a bad leaving group? Exactly, it cannot be stable on its own. Well, let's talk about that real quick. So this is gonna be our electrophile. Okay, and then OH is gonna be a nucleophile. So let's talk about nucleophiles versus electrophiles, chat. So remember, the more fun you make it, the more you're gonna lock in for OChem, and it's gonna be more fun. Okay, so this one's gonna be this is what I got here. So guys, I'm getting a lot of requests for SN1, SN2, E1, E2. So guys, let me just bring up that table one more time. So guys, I promise that I'm gonna lock in for some videos ASAP because I keep getting that request, SN1, SN2, E1, E2. So let's just discuss this briefly because I'm running out of time. But once again, don't worry, I will be back tomorrow. I'm gonna be posting the lives. Yes, I'm gonna be posting this tonight. Okay, thank you, Jackson. And guys, so SN1, SN2, E1, E2, you have to lock in for this table, my friends. Okay, so let's go one at a time. Okay, so nucleophile is gonna be something that is, again, loving positive charges. So it's typically gonna have a minus charge. So nucleophile only. So if it's a nucleophile only, that's gonna be for instance, bromine, okay, halogens, anything that has a minus charge. So all the halogens, bromine, iodine. Chat, what are all the halogens? Comment down all the halogens you know. Think back to your Gen Chem and comment down all the halogens you can think of. Okay, and then SH minus is going to be nucleophile. So if it's primary, you're going to do SN2. If it's secondary, you're going to do SN2 and SN1. If it's tertiary, you're going to do SN1 only. Okay, Jack Johnson says the right side of the periodic table, exactly. Now for bases, that's going to be only bases. So it's going to be non-nucleophile. So for example, H minus, DBN, so strong bases, things like that. If it's primary, it's going to be E2. Okay. Secondary is going to be E2, and tertiary is going to be E2. Okay. And then finally, strong nucleophile, strong bases is going to be RO minus and HO minus. Okay, that's going to be primary. Is SN2 major. Okay, SN2 major and E2 minor. You have to lock in for this, chat, and try to memorize this table. Secondary is going to be E2 major, SN2 minor, and tertiary is going to be E2 only. And last but not least, if we have a weak nucleophile or weak base, ROH versus H2O, primary is going to be SN2, E2. Will not occur. It's not practical because the reaction is too slow. And then for secondary, you're cooked because we have SN2, SN1, E2, E1. But it's not practical again, so E1 is not going to occur. And then finally, for tertiary, we're going to have SN1, E1. Okay? All right, my friends. So, guys, pretty much going to end it for today. I'm going to be on for about 5 more minutes, so you got time for one more question. Got time for one more question. And guys, anyone that's new here, comment the word new so that we know that you're new. Okay, if you've never been to a Dr. Drew live stream before, comment new. And guys, thanks so much for locking in with me. Pause. Guys, this is gonna be it for today, but I will be back tomorrow, same time. Join the Discord. It's free. So, Riley, welcome in. Hope that was helpful, guys. Appreciate y'all's support and interaction. Okay, the more you comment, not only is it good for me, but it's actually good for you. Okay. So guys, if you want to join the Discord, it's 100% free. Join that link in bio. Go to engineeringminds.co. Tap that link that says join Discord and then select your reasons why you want to join. Okay, I'm building out a community of STEM lovers, engineers, and future doctors. Okay, and guys, that's where you can ask questions, interact, and please, please, please introduce yourself if you haven't already. Okay, so that's where you can ask questions and meet other STEM majors. Guys, if you need tutoring, I got you. Okay, so you can book a free session and tap that link in bio. Click on book a free session. I got you for Gen Chem, OChem, calculus, and physics. Okay, if you're feeling a little bit stressed out, okay, I definitely got you. I got you for Gen Chem, OChem, calculus, and physics. So whether you're in high school or college, I don't want you to be stressed out. Okay, so you can book a free session and then we'll talk and see if we're right fit for each other. And last but not least, guys, I'm gonna be exploring the resource. I'm gonna be building out resources. So if you have a question, just click on this. Like let's say we pick one. Okay, let's say we pick one, and then click on where it says request a resource. So it says suggest a resource, topic, or problems to add. So this is a really good place for you to ask questions. So just put your topic, and let's say it's like Gen Chem, or you put OChem, and then you put a picture. You drop a picture of your question. Okay, and then you click next. Okay, it says files are missing, so you need to add something, and then click next, and then yeah, so then that's the best way to ask questions or join the Discord. All right, my friends, pretty much gonna end it. Thank you so much. Really appreciate y'all. Literally appreciate y'all so much. And thank you, Jackson. Invite your friends. Lupita, thank you for the love. Thank you for the follow. And yeah, guys, I will be back tomorrow, so make sure you drop your questions down in the Discord. Of course, my pleasure, Riley. Peace out, my friends. Have a great rest of your evening. I'll see y'all tomorrow. Stay safe. Show some resources. Okay, let me just show some resources real quick. So we have, let's see, we have chemistry. Okay, we have chemistry, we have calorimetry. Okay, so if you need to review your Gen Chem, calorimetry. Okay, let's see, we have some algebra. We're building out algebra. Soon we're gonna have calculus too. Okay, so just have fun there. Right now it's mostly Gen Chem. Okay, and then we're gonna have physics too. Okay, we have physics, and then let's see the algebra ones real quick. Mathematics, we have algebra here. Cool, cool, cool. Real numbers and their properties. All right, my friends. All right, my friends. Peace out. I'll see you tomorrow. Yes, Brandon, I got you. Don't even